Good morning.
Good morning. Okay, it's time to begin. Today we're going to cover synthetic division. Yesterday we covered long division. Okay, when dividing them in the divisor is in the form x either plus or minus a c, where c is just a constant number and x is just 1x to the first power, we can use synthetic division. Notice I say it won't work here if x is something besides 1x, and then it also won't work here if the power of x is greater than first power. Now, here would be an example of a problem you could work doing this. Likewise, if we had x plus 8, you could still work this problem using synthetic division. Okay, here's our first problem. Now, there are essentially 3 steps in setting this up. First, you write the value of c in a box. Remember, the c was this number right here. Now, write that. And when we write the value of c in a box, it'll always be the opposite sign. The reason for that is up here, this is in factored form. And remember, when you change from factored form to x equals form using the zero products rule, you add 8 on both sides, so you would get this. Now, in long division, we used factored form. In synthetic division, which is an additive process instead of subtractive, like, okay, long division uses multiplication, division and subtraction, and it uses the factored form. Synthetic division will use the root, and it will use addition and multiplication. So in other words, they work just the opposite, but to the same end. Okay, so in other words, our sign there will have to become positive here because we're using the root, not the factor. Okay, here we've just written down the coefficients of our 4 terms in the dividend. In other words, there's a hidden one there, the negative 13, the positive 46, there should be a plus here, and the negative 49. Now, we're continuing. This is where we left off. Okay, we're going to skip a line and draw a horizontal line, and then we're going to bring down the leading term. So in other words, we're just going to bring down that 1, whatever it is. If that's a 3, then we bring down the 3. Our next step, we take this divisor times the 1 to get our number to go here. All right. Now we're going to add these two instead of subtract. So negative 13 and positive 8 gives you a negative 5. This stuff is out of sequence for some reason. Okay, then we're going to take the 8 times the negative 5. And you know what? I don't know where this 40, oh, and it's 40 right there. 5 times 8 is 40. We add these two and we get a positive 6. 8 times 6 is 48. We add these and we get a remainder of 1. Now, you see this line right here. This line was before the constant. Now, with that line, that's going to denote that this is the remainder. Now, what we've got here is this. If you look back at the original problem, and I'm going to go back, got to go way back, x cubed, and then it went downhill. So originally this was an x cubed, that was an x squared, that was an x, and here was our constant. Down here in our answer, because we have divided out one x value, this is now an x squared, this is now an x, that's a whole number, and then out here we'll have the remainder. At negative 1, okay? So that's the way this one works. So we have reduced this by 1 degree. Now, what we've also done is we've taken this cubic and basically we have factored x minus 8 out of it. So we have changed this original equation, we factored it into x minus 8 times x squared minus 5x. This was a positive plus 6. And then with a remainder of 1. Negative 1 over x minus 8. Okay? Now, and I need to close this parentheses. If we took this times that, and then added, we would get the original equation. It'll be easier to see that when we get one without a remainder. Okay, let me erase my scribbles. Okay, here's our same problem still. So now we go back in, it's telling you you're removing 1 degree there. And it's showing you have, this is your square, this is your x value, this is your constant, that's your remainder. All of which I've already told you. Okay, what about this one? Okay, notice instead of using the factor value, I use the root or the x equals value. I had to insert two placeholders because I'm missing the x cubed and I'm also missing the x squared. So just like we did in long division, we've got to put in these 0 placeholders for synthetic division as well. Okay, we're going to draw our line and bring down the first term. 3 times 1 is going to be 3. Add, and we get 0. 0 times 3 is 0, and add, and we get 0. 0 times 0 is 0, times 0. 12 plus 0 is 12. Now 3 times 12 is 36, and I get a remainder of positive 3. Okay? But we reduce this by a degree. Again, here is your, what started as an x to the 5th is now x to the 4th, then 3rd, 2nd, 1st power, constant or 0 power, and remainder. So here's how we would write our final answer. We've got 1 x 4th. We don't need to write these down, but we do need that. And then we need to show the remainder. Okay, here's another one. We got this thing up here on the top. Now, notice I've got those two in backwards order. My factor is plus 10, so my root is minus 10. Here's my 3, my 25, my 48, negative 48, and my 20. I always like to put the positives on these just as an error prevention thing. Okay, I bring down the 3. Negative 10 times 3 is negative 30. Add, and I get negative 5. Times negative 10 is positive 50. I add, and I get positive 2. Negative 10 times 2 is negative 20. And now I get 0. When I get a 0 remainder, okay, that's a very special thing. Because what that means is x plus 10 is a factor of this, okay? And it'll go into it exactly. And that's part of what the remainder theorem is about that we'll talk in a few minutes. And once again, what are our powers going to ultimately be? This one's going to be 1 lower, 1 lower, 1 lower, and then of course the remainder out there. So our answer is going to be, and you can't see it down here, so I'll write it up here. Our answer is going to be 3x squared minus 5x plus 2. Okay. Now then, if I take this and I multiply it by x plus 10, in other words, distribute the x's, distribute the 10s, I would get the original problem only in the correct order. Okay, on this one, it's in the right order, but it's got some missing terms. So I've got 4 for the x cubed, Okay, I've got, and I'm just going to put an x cubed up here as a reminder for myself. And then I've got plus 0 for x squared. And then I've got minus 28 for x. And I've got minus 7 for the constant. Okay. I'm going to do my synthetic division by positive 3. Okay, I bring down. 3 times 4 is 12. 0 plus 12 is 12. 3 times 12 is 36. And I get a positive 8. Okay, and 3 times 8 is 24. So I add those and I get a negative or positive 17 remainder. So what is my answer in the end? I'm going to have 4x squared plus 12x plus 8 plus 17 over x minus 3. And that'll be my answer. Okay, let's do another one. I've got to put these in the right order. My highest power is 2x to the 4th. I got plus 7 for the x to the 3rd. I'm missing the x to the 2nd. Minus 3 for the x. And plus 5 for the remainder. I'm going to divide by -1 or do my synthetic division. So I bring down the 2. -1 times 2 is -2. I add 7 plus -2 is 5, positive 5. Okay. -1 times 5 is -5. I add these and I get -5. -1 times -5 is positive 5. I add and I get 2. -1 times positive 2 is -2. And I add and I get positive 3 for the remainder. So what is the answer on my problem? If I started with x to the 4th, then I've got 2x to the 3rd plus 5x squared minus 5x plus 2, strange looking 2, plus 3 over x plus 1. And that would be my solution on this one. Okay, so What have we done now? We've done long division, and we've done synthetic division. So now what we're going to try to do is we're going to go into the remainder theorem and what we call the factor theorems. Okay, the remainder theorem. Okay, you take the equation, you divide it by something. This should be x minus c. Right here, you can't see the minus. Then you get a remainder. Okay, now the value of the remainder is the same as the remainder we get if we divide this by that. Now, what does that mean? Okay, here's an example. We've got some missing terms, don't we? We have to put in the missing terms. We have to put in the x to the 6th, the x to the 4th, x to the 3rd, and x to the 1st. And here's our constant. Okay, we're going to divide by -1. Now, when it says f of -1, okay, what that means is x is -1, or in factor form, it would have been x plus 1. Okay? Now, so we're going to do this problem. We bring down the 5, do our multiply, add, 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 and we get, in this case, a remainder of -1. Okay? Now, what this is telling you is that when you get a remainder of -1, that gives you a value. Okay? Now, let's look at these. We want us to evaluate these. This is basically a sub and solve. And to do that, I'm going to get out of PowerPoint and go to my calculator, because I don't feel like multiplying 5 to the 4th power. Actually, I can. Those numbers aren't that terrible. So in the first case, if we find f of 5, then 5 to the 4th plus 5 to the 3rd minus 6 times 5 to the 2nd minus 5 times 5 minus 15. 5, 25, 125, 625. Okay, here, 5, 25, 125. Here I've got 6 times 25. And here I've got 5 times 5, which is just 25, minus 15. Well, 6 times 25 is 150. Okay? So this is a negative 150. Now we just got to add these up and see what we get. If this is true, our answer ought to be so 625 plus 125 is 750, which is 600. 665, and you get that. Okay. Now, what happens if we do this? Well, what they're wanting us to do is they're wanting us to take this thing and they're wanting us to do the long division on it, or the synthetic division on it. That's what they're wanting to do. So, you know, this isn't helping us that much. But what this is doing is here, I would add those up and that would give me the y value. Now let's look at this one. They're saying that square root of 5 is a 0 of this. So they're putting square root of 5 in here. They're changing this to synthetic. And you can see that it goes into it. Now, because you get a 0 remainder on this, what that 0 remainder is telling you is that, yes, square root of 5 is a perfect 0 of this equation, and it's also telling you that x minus square root of 5 is a factor. If x equals square root of 5, then x minus square root of 5 would be the factor. And yes, this will divide exactly into that. If we use this with long division, which we could, it'd be a pain, we would still get a 0 remainder. Now that's what this thing is all about. So let's go back into here and see what happens. Here, I went the wrong way. I want to go back to this. Now, what they wanted us to do was to take this equation, a 1, which this was an x to the 4th, plus a 0, or excuse me, a 1 for x to the 3rd, minus a 6, minus a 5, minus a 15. And they're wanting us to do this problem. Okay? They're saying test is f of 5 a solution of that. So we bring down the 1, we get a 5. We add them and get a 6. 5 times 6 is 30. We get a negative 24. 5 times negative 24 is negative 120. Okay, and so you're coming out with the same sort of a thing that I did before. These two would give you a negative 125, and 5 times negative 125 is negative 625, which corresponds to that substitution that I did before, which we would get a big remainder here of negative 640. Now, what does that tell us? That tells us that 5 doesn't work. That tells us that 5 is not an x value. It also tells us that x minus 5 is not a factor, because we would have gotten a 0 remainder if it had been true. Now, like I said, you can use the substitution thing and get the same results. Now, they did square root of 5 in that one. So now let's go on. This time they're saying, show that the imaginary number 8i actually is a factor of this. Now, when would you get something like that? Remember when we did the quadratic formula? And sometimes down at the end, when you get through, you would get x plus 8i, x minus 8i for the positive and negative sides, okay? So it is possible, like if you did the quadratic formula, that you could get this value as x values for the problem. So now we're going to put in the 8i up here, and we're going to try this. I've got to watch my time today because another teacher's coming in. Okay, putting it in scientific notation or synthetic notation, bring down to 2. 8i times this is that. Subtract them and we get this a plus bi. Now we take 8i times this, we distribute it. 8i times 1, 8i times 16i. You get an I squared thing in here, which causes that to become minus. Okay, now we combine these. We can only combine these two parts and the 8i remains. Now I take 8i times 8i, which is 64. It's actually positive 64i squared, which is positive 64 times negative 1, which is negative 64. And in this case, I have a 0 remainder. What that means is that 8i is a factor of this equation. Okay, or 8i is a 0 of this equation. So what that also means is that x minus 8i, remember if it's positive out here, it becomes negative there, times 2x squared plus in this case 1 plus 16i x plus 8i. Okay, that thing, if we multiplied this thing out, okay, so here x times this, okay, all of that, we'd have this 2x squared here, and then x here, and then 16i x, and then plus 8i. Supposedly this times this would give you that. Now, there's a rule that we're going to come up with in the next day or two. If there's one imaginary, its conjugate is there also. So the next thing we would do is we would take this and we would divide the negative 8i out of it. Because anytime there's an imaginary number or a square root, it's got to have its conjugate in there. Okay, here's 3 problems. They're telling you to try 2 to see if it works. Then they're trying to tell you to do square root of 7. Then they're trying to tell you to do those. We're going to skip over those for now. The factor theorem. Now, on the remainder theorem, the thing that you need to know is that if you get a remainder, then that means that you did not have a factor you were dividing by. It's not a perfect factor. However, that remainder becomes the y value for whatever you divided by. And we'll show that a little bit more next week. Okay, the factor theorem. Okay. Let's go into this and see. We're testing to see if x plus 4 as a factor or x equals -4 is a solution of this problem. Okay, so we're going to divide by the -4. Here are our values, and we get no remainder. Since this goes into that perfectly, what that says then is -4 is a real root of this problem, and x plus 4 is a real factor of this problem. Now, what we've also done in this, because this becomes x squared, this becomes x, okay? This value right here, if the problem said find all roots of that equation, by doing this division with that -4, we found the first root. Now, we can either factor this or use the quadratic equation, since it's down to the second power, to find the second factor. And then that would also give us the third factor, because this would either break into 2 of these, or you would be, like I said, be able to do the quadratic equation. And we're going to learn what numbers to try to use in the quadratic equation in the next section. But anyway, what this whole process does, whether you use dividing long division or whether you use synthetic division, the whole purpose of it is to see if you can get a zero remainder either way. And if you do, you have factored down one step that equation. Okay, that's the whole purpose of this. It's taking higher degree equations and taking them down one step at a time until you get them to a second degree where you can either do normal factoring or use the quadratic equation. And this is telling you what I just said. Okay, what they're wanting us to do is they're wanting us to try x minus 6 and see if that's a factor of this thing. And we'll know because we get a 0 remainder. And then there also is a separate problem wanting us to try x plus 3 just to see if those will factor into it. Now, before we even start, I'm going to try to use my pointer up here. See this 6, the constant on the end of the real problem. Okay. Here you've got a 6. 6 goes into 6. That's a possibility. 3 goes into 6. So that's a possibility. Now, will they go for sure? We don't know until we try it. Okay. So let's go through and do these two problems. Okay, so I've got 2, negative 13, positive 10, negative 25, and positive 6. This time I'm going to divide by positive 6. Okay, so bring down the 2, I get a 12. Gives me negative 1, I get a negative 6. 6 times that, or add those rather, I get a 4. 6 times 4 is 24. I get a negative 1. 6 times negative 1 is negative 6. I get a 0 remainder. So what that's saying is that this is a perfect factor of that. And this equation is now 2x to the third minus 1x to the second minus plus 4x minus 1. Okay. So what we've done is successfully this times that will equal that up there. So we've taken this down 1 degree. Now we would need to do this process again to see if there is another factor that'll break it down. Because we can't use the quadratic formula yet, because that has to be a second power before we can do that. Now let's try this other problem. Instead of a 6 here, I'm now going to have a negative 3. Bring down the 2. Negative 3 times 2 is negative 6. That gives me negative 19. Negative 3 times 19 is positive 57. That gives me 67. Negative 3 times 67 is, I don't know what. 3 7s are 21. 3 6s are 18, and 2 makes 20. 201, and the sign's going to be negative. So this gives me negative 226 times negative 3 is 678. And it's going to be positive. So this would give me 684 remainder. Well, that one doesn't work. That's all this tells us. Okay. It also tells if x is negative 3, that y is 684. And we'll cover that a little bit more in the next couple of days. Okay. So this one is a factor. That one is not a factor. Okay, here's another one. We're given this equation, 5th, 4th, 3rd, 2nd, 1st, 0. So all the terms are there. Wants us to see if x minus 6 could be a factor. Well, because 6 will go into 6, it's a possibility. If that had been a 5, we don't even need to try that to see, because 6 won't go into 5 exactly. Okay. Now, if this had been a 36, we could still try it. What if this had been a 2? Well, 2 goes into 6, so we could still try it. But if this number won't go into that number, it can't come out without a remainder. It has to have a remainder. Okay, so there's speculating is x equals 6. So here's the work on it. They've already shown all the work. In this case, it works. And it drops this thing down by 1 factor. So what that tells us is that x minus 6 times this reduced by 1 power equation are true factors. Now we would take this equation and try something that has a 1 in it, or a positive or a negative 1, okay? Well, in fact, we actually can factor this thing using that U rule, because this factors into this times this. This will factor even more, which you can't see down here. This is x minus 1, x plus 1. Okay, this will not factor right here, because this is going to give you an imaginary number. And I don't know if there's any way that I can show you that, what that is. Okay. Well, actually, they don't show you that. So I'll show you over to the side. Okay, this term right here. Okay, remember this one is x minus 1, x plus 1. Okay, but this when we set it equal to 0, take the square root of both sides, plus or minus. Okay, we get 2x or 4x here, 2x, excuse me, 2x there, and over here we get plus or minus I. Divide both sides by 2, and x is going to be plus 1/2 I and minus 1/2 I. So in this case, it would be very difficult to do that. But if we tried positive 1/2 I or negative 1/2 I in this equation, we would get a 0 remainder. Okay, here's another one. Notice what the instructions are. Factor it. Well, the way we're going to factor it is we're going to try -4. What they're checking to see is they're speculating is x plus 4 times something, a factoring out that. So let's put our 2, which this was an x cubed to start with, plus 7 minus 14 minus 40. And let's divide it by -4, because they say that -4 is the factor. So plus 4 is, -4 is the 0, so plus 4 is the factor. Okay, so I bring down the 2 and I get -8. There's -1 and I get +4. And here's -10 and I get +40. 0 remainder. So what we have done is we have factored this down one step so that we've got x plus 4 times 2x squared minus x minus 10 are a pair of factors for this. Now, that value I can put into quadratic formula to factor even farther, so it's all the way down to just pure x values. Now, why do we want to do that? Think back earlier when we were graphing. One of the things we had to do is find all the points where x was on the x-axis. Okay? This is the way we get down here. Here's a point where x is -4. This will give us 2 more points because it's a square. Okay? So this is all a process of working down so you can get all the x values of an equation. Now, I want to show you one more way of doing this, a third way. I've shown you synthetic, I've shown you long division. I'm going to show you a third way, that's substitution. 2x cubed plus 7x squared minus 14x minus 40 equals. If I substitute everything, all the x's with -4, okay, here I get -8. 4 times that is positive 16, and 16 times 7, 6 times 7 is 42, 7 and 4 is 11. Okay, these two, 4 times 4 is 16, 4 and 1 is 5, and it's positive, and minus 40. Okay, what do I get when I add all of those up if I've done it right? Okay, oh, I didn't do this right. I left off the cube here. That's 64, which is 128, negative 128, and this is negative 64. Okay, so if I take negative 128 and I take negative 40, that gives me negative 168. And if I take 112 and I take 56, I get positive 168. 0 equals 0. And it checks. So you can do it by substitution, but believe it or not, it's faster to use the synthetic division if you possibly can than it is to even use substitution. But this is your safety valve method. And with that, we're done for the day. So I've got to get shut down for another class. Okay, bye.